Okay guys, so our last video is we're going to talk about comparing z-scores, and really honestly this is like what it's all about. This is why we're computing z-scores, is so that we can use that information to compare it to other scores. So let's start off. Again, I've said this I think in every single one of these videos, that allows the researcher to compare two scores that are from different distributions. So like for instance, we compare two different test grades that are on the same scale. Maybe they're all 0 to 100, but they have different means and different standard deviations. So we can compare those two test grades together. Even though they're on the same scale, they have different means and different standard deviations, meaning that one test might be closer grouped to the mean, whereas the other one might be more spread out. So which one did you do better on? Well, it depends. So it allows us to do that, but it also allows us to compare grades that are on different scales. So like for instance, the SAT scores from 400 to 1600, and then the ACT goes from 1 to 36. Well, if you get a score of 1200 on your SATs and you get a score of 26 on your ACTs, which is the better score? Well, they're on two different scales, so it's very difficult to see without doing your z-scores. So that's, again, really what we're doing with z-scores, is we're uniforming the data so that we can compare them against each other and decide who did better or worse on whatever. Remember that the higher your standard deviation, especially if we're talking about wanting to know which did better as far as an exam, would always be the higher standard deviation, because the higher your standard deviation, especially positive, that means the further you are from the mean. Okay, and that's what we're wanting to do when we talk about a test score, is I want to be on the positive side and I want to be as furthest from the mean as possible. That means I did better on that exam than everybody else, or than a certain percentage of people. Okay, so the larger the score, the further the distance from the mean. So a score of 1.5 would be better than a score of 0.7. And now this is if we're talking about on the positive side. Okay. So let's look, for example, we're trying to decide if we want to go to law school or medical school. So if we took the entrance exam for both, we took the LSTAT for the law school, and we took the MCAT for the med school, and we want to use the chart to determine which test we did better on. So we're going to do the z-scores for the LSTAT and the MCAT based on our scores we have here. So the mean for the LSTAT for the law school exam is 151. The standard deviation is 10, and our score was 172. So we're going to do our z-score. Remember, it's the score, 172, minus the mean, 151, divided by the standard deviation, which is 10. And we get 21 divided by 10, or we got a 2.10 z-score. Okay, so that is a little over 2 standard deviations from the mean. All right, so let's do the same thing for the MCAT. On the MCAT, the mean is 25.1, the standard deviation is 6.4, and we scored a 37. So we're going to do the same thing. We're going to do our score minus the mean divided by the standard deviation. So we've got 37 minus 25.1 divided by 6.4. So we're going to 11.9 divided by 6.4, and that is a 1.86. So still pretty good, right? You're almost 2 standard deviations above the mean. But if we're looking at which one we did better on, we actually did better on the LSTAT, because our standard deviation was higher. Our z-score was higher. We were further from the mean on that LSTAT, which means we scored better on that exam than we did on the MCATs. So if you're going with which one you should go with, we go with law school, because we did better on the exam there. If you need another example of how comparing z-scores works, please let me know.